Hey guys, Mr. Maestas here, and this is number 8 in 2-1 for the Essentials of Calculus. So this is for AB Calculus. What we're going to be doing is determining the limit on a TI-Nspire. So the first one I'm going to do is how to do this on a TI-Nspire CX. And then I'm going to show you how you can actually do this really quickly on a TI-Nspire CAS version. Alright, so 1 second here. I want to make sure that we're doing the correct limit. So the first one here, we've got number 8. By the way, this is not number 1, this is 8. Okay, so this is number 8 on our workbook here. We're trying to find the limit as x approaches 1 of x cubed minus 3x squared plus x plus 2 all over x cubed minus 2x squared minus x plus 2. So what we're going to do is we're going to go to a graph, and we're going to go ahead and graph it. So here's my graph of the function. And what we want to do is we want to find values very, very close to 1. So if we notice here, x equals 1 is right here. It looks to me like graphically we're going to go up to infinity and down to infinity, but we want to make sure. So what we're going to do is we're just going to do a little bit of numerical analysis using our table. So I'm going to hit menu, and I'm going to hit table, and I'm going to split screen this table so I can see both the equation and the graph and my table. So notice here, as if I go click on the table here, and I have 1 is undefined, and well, look at that, 2 is undefined. So at 1, at x equals 1, my graph is undefined. At x equals 2, my function is undefined. At x equals -1, it's also undefined. So what I'd like to do is get a little bit closer in here. I want to get a little bit closer to 1 right here, x equals 1, and see what's going on, because all I know is it's equal to 1 at 0. So I'm going to change my format of this table. I'm going to hit menu, table, and I am going to do edit table settings. So what I'd like to do is I'd like to start my table at 0, and instead of stepping at the x values of 1, I'm going to step at x values of 0.01. I'm going to go ahead and hit auto for those and hit OK. And so now you see that it's much smaller here. I've got values 0.08, 0.09, 0.01, and so forth. So I'm just going to scroll down till I get really close. As I get closer and closer, notice what's going on. What's going on here? They're getting very big, right? 9, 10, 13, 17, 25, 50, and then it's undefined. Okay, so these are getting very, very much larger. And then here, they're negative. So it goes, as I get closer and closer, going up to 1, as I get closer and closer from the right, that's going to negative infinity. Now I can see, if I wanted to, I can see that even closer. So I can go ahead and hit menu, table, edit table settings. Table start at 0.98, and I'll go 0.01. Okay, look at that. Now let's see as I get closer. 31, 30. Look at that. They're getting even larger. 500. 0.999 is 500. Over here, they're negative. So I would say the limit as x approaches 1 from the left is going to positive infinity, and as it approaches from the right, it's going to negative infinity because it's undefined. So when I answer my problem, I would say this does not exist. Right, D and E. Let's do the second one, as x approaches 2. So I'm going to go back, do the same thing. I got to change my table settings here. So edit table settings. Let's start at 1.998. Let's start at 1.99, go by 0.001, and let's see what happens here. All right, so let's get larger as we go to 2. It looks like these numbers actually are getting closer and closer to 0.33 maybe. Let's check on the other side. 0.336, 0.335, 0.3349, 0.3344, 0.3338. So both times they look like they're getting closer and closer to 0.333. If we want, we can even cut that down even more. Let's just get a little crazy here. Go even more further. All right, let's go going towards 2, right? Okay, there we go. 2 is undefined. So look at that. As we get closer and closer to 2, we get 0.333277, 0.333388. So it looks like, what do you guys think? It looks like it's going closer to and closer to 0.333. So again, in calculus, right? We want to have 3 decimal places. So I'm going to say this is getting closer to 0.333. All right, so not too bad. Now, check this out. If you are using it, so that's how you would do it in a TI-Nspire CX if it's non-CAS. If this is a CAS version, I'm going to go and just copy this. And I'm going to paste it right here. All right, so a CAS, I'm just going to ask it, hey, CAS, what's this limit? And it tells me, hey, you that asked me, what's that limit? It's 1/3. And then I say, hey, that's pretty cool, CAS. You're awesome. And then I'm done. All right, so the CAS knows how to do things like that. Let me do this one here, see what that does. Control C, Control V. Undefined. Hey, it's undefined. I said that's right. That's what I had. It does not exist. So there you go. So that's how you find a limit in the TI-Nspire or the TI-Nspire CAS. We'll catch you guys later. Bye.